So in this particular case, there is a business problem given to us, right? So we all know what is this? This is a card deck, right? So I'm going to take that example for our simple understanding of probability, right? Because our course is at very simple level, and I'm going to even convert the complex things with the simplicity for your better understanding, right? So let us understand the probability, how to calculate the probability from this very example. Okay, so this is a card deck which normally has 52 cards, right? The ranks over here, the numbers over here, this particular page will get the first value, that is the rank number 1, and these are going to get the 11, 12 and 13. So let's have some fun to learn the probability, right? Now the question given over here is, suppose you randomly pick a card from this particular card deck. Okay, what is the probability that this card will be bigger than 10, which means greater than 10, right? So now we have all these 4 different types of cards, and there are total 52 cards, right? So starting from 1 to 13, these are the numbers or the values or the ranks or the weightages they are carrying. Now what we are interested in? We are interested in bigger than 10. And what is the probability definition we have seen? We have seen the probability of y is equal to number of interested event divided by total number of events. Meaning which, currently with this problem, I am interested in the cards greater than 10. So how many cards are there which are greater than 10? Right? So there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 cards which are greater than 10. So I am interested in these 12 events. Divide by how many total number of events possible over here. If I randomly pick a card, how many different outputs can I get from this 52 deck card? Obviously, total number of events are possible 52. So the probability that this card will be bigger than 10 is going to be 12 by 52, right? Similarly, now we will understand the second question. So let me keep it like that. And let me remove all this. Right? So probability of, now we are interested in to find out what is the probability that this card will be equal to or bigger than 10. That is, we are interested in to find out probability of card. So I am saying probability of card equal to 10 or greater than 10 is equal to, okay, that is going to be the value over here, right? So now if I am interested in the card which is equal to or greater than 10, which means greater than 10 we have already seen, so these are greater than 10 area for the cards, okay. So we have to add this one because we are now saying equal to 10 as well, right? So we are going to consider these 4 cards, these 4 cards, these 4 cards and these 4 cards. So here again, if you see the definition of probability, how many number of interested events are there, or how many number of events in which I am interested in. So I am interested in earlier 12 plus this 4, that is 16. So I am interested in 16 number of events. Divide by how many total number of events possible? 52 again, right? So this is going to be the probability that if I pick a card from the card deck, then the probability that this card will be equal to or bigger than 10 is 16 by 52, right? Now let us check the third example. So in third example as well, the ranks remain same, 11, 12 and 13. Now we will see, if suppose you pick randomly a card from this card deck, what is the probability that this card will be smaller than 3? So now I am interested in probability of card less than 3 is equal to number of interested event divided by total number of events. So now we are interested in this area, this portion. So how many cards are there which are smaller than 3, right? So not even this, because this is smaller than 4. So actually not this one. The area I am interested is, or the numbers or the events I am interested in, less than 3, that is this. So 1, 2, 3, 4, 5, 6, 7, 8. So I am interested in these 8 cards. So my number of interested event becomes 8 divided by how many total number of events possible? Again, total number of events possible are 52, because if I randomly pick a card, all 52 cards are possible, may get picked by me, right? And now let us understand the final example. So what is the probability that that card will be greater than 4 or less than 8 or between 4 and 8, right? Which means I am interested in these number of events, right? So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So number of interested event becomes 12 over here. Divide by how many total number of events possible? 52 total number of events are possible, right? So this is how the probability works, or this is how we calculate the probability. These were the examples of calculating the probability. Now let us understand something called as probability distribution, right? So as we know, there are 2 different broader categories of data, and that is why, and what are those? The categories of data types are continuous or discrete. Of course, within discrete there are three subcategories, but then for these are the major categories or broader categories. And that is why whenever we are discussing about probability distribution, there are two types of probability distributions. One is continuous probability distribution and one is discrete probability distribution. And what is the definition of probability distribution? So it is like a chart which is given here. Okay. So probability distribution is something when we have a plot between x and y axis, wherein x is having the probability, x is having the number of events, x is having the values of a random variable, x is having values of a random variable, and y is having the probabilities associated with those random variable values. Let me repeat, let me write it in a different way. So there are two types of probability distribution. One is continuous probability distribution, the other one is discrete probability distribution. And probability distribution is a plot when we have values of random variable on x-axis and probabilities associated with that random variable values on y-axis. So when we have a plot, and when we have within that plot the random variable values on x-axis and the probability associated with that random variable value on y-axis, then we call it as a probability distribution chart or probability distribution. So this is a probability distribution given to us for this given data. We will understand that what is the data and how the distribution has plotted, right? So the data given to us is the daily sales of a large flat panel televisions at store X, capital X, or it can be ABC, it can be PQR, right? Anything, any value, any store name will be there, right? And these are what the number of TV sold on daily basis, right? And these are the probability associated with those number of TV sales on daily basis. Now there is a 40% chance or probability that in a day 0 televisions can be sold. This is what the interpretation of this data. There is 25% of chance or probability that we may have a sale of one television set. There is 20% chance or probability that we may sell two televisions in a day, 5% for 3 television and 10% for 4 television. If you add this total, you will get 100 or 1. Right? So from here, one more thing it shall come into our mind, that when we have seen the example of tossing a coin, then there were two outcomes possible, head and tail, and the chance associated with both of them was 1/2 and 1/2. In rolling a die, the possibilities were 1, 2, 3, 4, 5, 6. There are 6 outcomes possible, and the probability associated with each outcome was 1/6. So from this total, I want to make clear one thing, that if you add the probability associated with the outcome of any event, and if you add them all, it will be always 1. If you add this 1/6, 1/6, 1/6, 1/6, 1/6, it will be always 1. And here also the data is complete, so all the probabilities given over here and the total is 1. Right? So the probability associated with the all outcome possible for any given event, the summation of all those probabilities will be always 1. Right? Now from this given data, we have to understand what is a probability of a sale. What is the probability of a sale? Now when we are asking it in this way, that what is the chance of a sale, means we are talking about at least one television. Right? So to answer this, one can also use this logic, that it is equal to 1 minus, because the total probability will be always 1. So 1 minus probability of no sale, which is equal to 1 minus, what is the probability of no sale? 0.40, that is 0.40, which means it is 0.60. So there is a 60% chance that there is a probability of a sale happening, which is nothing but the addition of all these values. Now what is the probability of selling at least 3 television? So when we are saying at least 3 television, we are talking about minimum 3 televisions and above. So the probability of selling at least 3 television is probability of, from the data of course, probability of selling 3 TVs plus probability of selling 4 TVs, which is nothing but 0.05 plus 0.10, that is 0.15%. So there is a 15% chance that at least 3 televisions will be sold in will be sold in a day. Right? So this is how probability calculation happens. This is another example we have seen, and this is how the probability distribution chart look like. So if you plot this television sales, that is the random variable's value. So this is x is my random variable over here. It can take any possible value. We have already seen the definition of random variable, right? And these are the values which are the probabilities associated with that particular random variable value, right? This is associated for 2, this is associated for 3, this is associated for 4, and if I plot them like this, right, so 40% is the probability for 0 television sale, right? 10% is the probability for how much? How many? 4 television sales, right? This is 0.05, this is 0.20, and this is 0.25, right? So whenever we plot the random variable values on x-axis and probability associated with those random variable on y-axis, then we will get a plot of probability distribution, right? As we have seen that there are 2 types of probability distribution, that is, one is continuous and one is discrete. So which kind of probability distribution is this? Obviously it is going to be a discrete probability distribution. It is going to be a discrete probability distribution because the random variable values which we are having over here is a discrete count data which is plotted on x-axis, right? And that is why it is called as a discrete probability distribution. Similarly, now this is an example of discrete probability distribution. What can be an example of continuous probability distribution? So if I plot the values of random variable on x-axis which are continuous in nature and the probability associated with that random variable value on y-axis, then the chart, whatever chart I am going to get, will be called as continuous probability distribution, right? So here you can see I cannot have 1.5 television sales. Can I mention this in decimals? Is it making sense? It is not making sense to sell 1.5 televisions. It is not making sense to make 3.37 television. So I cannot have values between these 2 values of a random variable, and that is why it is a discrete count data. But if suppose I have a temperature over here or age over here, then I may have a value between that, right? In case if I get to plot let's say height of weight of a person, and probability associated with that particular person, I mean that particular weight of the persons, then what I will get? I will get a continuous probability distribution, because if suppose this weight is 10 kg and this weight is 20 kg, there are numerous values possible between these 2 values, right? So if I convert the continuous data into a respective bins, that is 0 to 10, 11 to 20, 21 to 30, something like that, then I will get it a discrete probability distribution, a bar-like structure. Otherwise, if I keep plotting without creating the bins, the probability associated with all the persons available on earth, then what I am going to get? I will get a smooth curve like this, because there are a lot of values possible between the 2 weights, right? Suppose I am having a weight of 78.80 kgs and someone else is having a weight of 79.7 kgs. There are infinite numbers possible between these two numbers, right? Whereas here no number possible between these two numbers. Why? Because this is talking about the count of television. So after one television we can have two television or we can have three television. We cannot have a between number over here, whereas here it is a possibility. And that is why if I want to have a continuous probability distribution, I need to have a random variable also continuous in nature. Alright, so that's it for a day, guys. So today we have understood probability with couple of examples, and we have also seen the probability distribution. There are two types of probability distribution, that is continuous and discrete, and we have also understood the definition of probability distribution, right? And we have seen the example of that.